This video is to help you do the online exercise on geometric sequences. What is the next number in this sequence? 10, 20, 40, 80, 160. Pause the video while you have a think, but you should soon notice that each term is multiplied by 2 to get the next term. 20 is multiplied by 2 to get 40, 40 by 2 to get 80, 80 is doubled to get 160, and if we multiply 160 by 2, we'll get 320. What about this sequence? What's the next number in this sequence? This time, we have to multiply each term by 3 to get the next term in the sequence. So, the next term after 162, we need to multiply by 3 and get 486. Now, what about this sequence? The second term is -8 and the fourth term is -32. What do we have to multiply this time? Well, if you multiply 4 by -2, you'll get -8. And then if you multiply -8 by -2, you'll get +16. So this time, the multiplying factor is -2. And if we multiply 64 by -2, we'll get -128. What about this sequence? Each term seems to be a little bit smaller than the previous one. So what do we need to multiply by this time? Well, we actually need to halve each term to get the next one. We need to multiply by a half. So 32 multiplied by a half, 32 halves, is 16. And half of 16 is 8, half of 8 is 4, and if we multiply 4 by a half, we'll get 2. So the next term is 2. So this is called a geometric sequence. And a geometric sequence is a sequence of numbers where each term is obtained by multiplying the previous term by a fixed amount. So what about this sequence? We've only got 2 terms. And I'm trying to figure out what we have to multiply 6 by in order to get 33. Well, you can use your calculator to help you. Because if you divide 33 by 6, you'll see what that multiplying factor was. It's 5.5. So, multiplying 6 by 5.5 would give you 33. So to find the next term, we multiply 33 by 5.5, and we get 181.5. What about this one? The second term is smaller than the first. But we could still use the same technique as long as you remember it's the second term divided by the first. So the 54 divided by 72 will give you 3/4. So the multiplying factor in this case is 3/4. 3/4 of 54 is 40.5. So how do we describe this geometric sequence here? Well, we could describe it by saying what the first term is, and we've all decided that it's a good idea to use the letter U to stand for the terms of a sequence, and the little subscript 1 to reflect the fact that it's the first term of the sequence. So in this case, U1, the first term of the sequence, is 2. And the multiplying factor we call the common ratio. And we use the letter R to stand for that ratio. And in this case, it's 3. We multiply by 3 each time. And in this particular instance, the number of terms is 6. So we use the letter N to stand for the number of terms. So what is the formula for the nth term of this sequence? Well, I can see that the first term is 2, And I can see the way we obtained the second term was by multiplying that first term by 3. And the way we obtained the third term was multiplying the first term by 3 and then 3 again. So I've written it as 2 times 3 squared. And then the fourth term was 2 times 3 to the power 3. Can you see the pattern? And have you noticed that the power of 3 is actually 1 less than the number of the term? So for the fourth term, the index is a 3. For the third term, the index is a 2. It's always 1 less than the number of the term. So in general, the nth term, where n stands for any number, can be written like this. The nth term, un, is the first term multiplied by the common ratio raised to the power, and remember we have to subtract 1 from n to get that power. So what is the formula for the nth term of this sequence? Pause the video while you have a think, and then I'll show you that, well, we use that general pattern of taking the first term and then multiplying it by the common ratio raised to the power n minus 1. So that's the formula for the nth term of that sequence. And now I can use that formula. So let's say I wanted to find the 18th term of the sequence. Well, if n is 18, we could write the formula down like this: 10 times 2 to the power 18 minus 1. And then with a calculator, type that in. 10 times 2 to the power, well, 18 minus 1 is 17. I won't use the calculator to work out 18 minus 1. And it gives us the answer 1,310,720. Okay, so here's the formula for another geometric sequence. Can you write down the first 6 terms of the sequence? Pause the video, have a go, and then I'll show you. Well, I can see from the formula that the first term is 81. And then the common ratio is in those brackets. It's a third. So I need to find a third of 81, 27. The second term is 27. Then I find a third of that, 9. A third of that, 3. And carry on until I've got my 6 terms. Those are the first 6 terms of that geometric sequence. But sometimes the formula can be simplified or written in a different way. So this is also a geometric sequence. And the way you'd work out the first term here is think, well, the first term is when n is equal to 1. So when n is equal to 1, we have 5 to the power 1, which is just 5. The second term will be 5 to the power 2. That's 25, 5 squared. And the third term will be 5 to the power 3, 125. And the fourth term, 5 to the power 4, 625. Right, we've got a sequence here with a missing term that's been replaced with the letter x. Can you see what x stands for? Well, I can see the common ratio must be 2. Each term is twice as big as the one previous. So x must be twice as big as a half. X must be equal to 1. But what if the numbers were a little more tricky? Here we have the first term of this sequence is 100. The third term is 2500. So I can see that when you've applied the common ratio twice, you get a multiplying factor of 25. So I think the common ratio must have been 5, because 5 times 5 is 25. So if the common ratio is 5, 100 times 5 is 500. X must stand for 500. Now as you work through the exercises, you will get to the exercise that requires you to find the sum of n terms of a geometric sequence, and the formula is here. If you're interested in where the formula comes from, pause the video now and have a look at this. but otherwise that formula will help you do the exercise. And if the common ratio is less than 1, if it's a fraction, a small fraction less than 1, and if we have a very large number of terms, so n is a very big number, that fraction to the very large power will tend to 0. So we have another formula for the sum of an infinite number of terms of a geometric sequence where r is less than 1 is that more simple formula. So geometric sequences occur in real life. Here's a question from a previous exam paper. Chris received a message at 8 a.m. At 8:05 he forwards the message to 4 people. 5 minutes later those 4 people each forward the message to 4 new people. Assume this pattern continues, and each time the message is sent to people who have not received it before, the number of new people who receive the message forms a geometric sequence. 1, 4, and so on. So the 4 questions are to write down the next 2 terms of that sequence, to find the common ratio of that sequence, to calculate the number of people who will receive the message at 8:40 a.m, and to calculate the total number of people who will have received the message by 8:40 a.m. Pause the video, have a think about that, see if you can answer the questions. I'll show you the solutions now. Here we have the solutions. Check you're working. Okay, now it's your turn to have a go at the online exercise. Don't forget to press the check button regularly as you're working through the questions to see if you're getting them right. And if you make a mistake, have another think and correct your answer and then press that check button again. Don't forget to claim your trophy when you've got to the end. And there are lots more activities on the Transum website for you to have a go at to improve your mathematics, and you can claim hundreds of trophies. So, what are you waiting for? Get going! Bye!
You can find Transum Mathematics at www.transum.org, where you're welcome to use all of the activities absolutely free. Or jump in with both feet and become a Transum subscriber.